This is understanding the makeup of connective tissue. 4 types of tissue in the body: epithelial, connective, muscle, and nervous. When we looked at the characteristics or properties of epithelial tissue, one of our characteristics was that it has cellularity. And cellularity means that the cells are tightly packed together relative to the other tissue types. And that structure creates the function. It provides physical protection, but it's also controlling permeability. So cellularity in epithelial tissue, we don't see that in connective tissue. Connective tissue is our most abundant tissue. But the difference with connective tissue is that it creates something. Now these cells become specialized because they create what we call the matrix. And we'll get into that. So we don't see that cellularity. It's less cells and more of the product they build. So their functions, we talked about our breakdown of classifications, the structural framework. We talked about cartilage and bones and tendons and ligaments. Transport fluids, we talked about blood and lymph to move things throughout the body. We said protect the organs, going back to bones is our primary way to do that. Storing energy, adipose tissue is one of our connective tissue proper, our loose connective tissues. Adipose is a great insulator and a good cushion. And then defense against microorganisms. One of our fluid connective tissues is lymph. And we talked about briefly our leukocytes, which are white blood cells. And we'll get into the different types once we get to the lymphatic system. So basic functions. But connective tissue is really 3 components. Instead of just cells like cellular and epithelial tissue, now these cells are special, they're specialized, and they're making something called a matrix. And the matrix includes 2 things: protein fibers and a ground substance. There's 3 types of protein fibers that we'll see. And then the ground substance is that general material around the cells. So when we look at bones, it's hard. When we look at cartilage, it's a little bit more softer and gelatinous. And then we can see it as a liquid when we look at blood and lymph. So that ground substance and that material changes. So for example, when we get to bone, that ground substance is a lot of calcium phosphate, one of the hardest materials in our body, calcium carbonate, so calcium based. So it just depends on the type of tissue, on the buildup of it. But it's based off the protein fibers to help support it. So specialized cells that make a matrix. When we talk about the specialized cells, we can start naming them, just like we did epithelial tissue. They're called fibroblasts, chondroblasts, osteoblasts. These are general terms to describe, these are the active cells that are blasting off the younger, immature cells that secrete the matrix. So when we refer to fibroblasts, they're making fibers. So the protein fibers are below the primary cells that make fibroblasts. We tend to see them more in connective tissue proper. Remember, connective tissue proper, fluid, and supporting from our last video. So fibroblasts are making fibers. Chondroblasts is referring to cartilage. So they're the primary cells that are specialized to make cartilage. Osteoblasts is referring to bone. So osteoblasts are making the bone material. One concept throughout the course we cover is differentiation. Differentiation is how cells can change over time and their role changes. No different than you as an organism. You change from a baby to a child to a teenager. As an adult, you change jobs, you do different things, you become older. You're the same person, but you've changed over time. That's what happens with these cells. A fibroblast can turn into a chondroblast or an osteoblast, but as the fibroblast gets older, it's called a fibrocyte. It's the same cell, it just got older. So a fibroblast becomes a fibrocyte. A chondroblast becomes a chondrocyte. And an osteoblast becomes an osteocyte. Now there is more of an embryonic stem cell start to this that we'll get into later as we cover the different types of tissues. But for now, the specialized cells, one that secretes the matrix, blasts, fibroblasts, chondroblasts, osteoblasts. They become older and help maintain the tissue. So they're kind of like the parents of the elderly. Once we build the house, they just maintain it. Fibroblasts, chondroblasts, osteoblasts. The fibers that they make. So collagen, reticular, and elastic. Remember we said these the primary cells that are making these are fibroblasts because we said specialized cells make a matrix. What's in the matrix? Protein fibers. It's the structural support for the tissue. Collagen is our most abundant. We see that quite a bit. It's because it's strong, gives me that tensile strength. Where we see a lot of the collagen fibers is my tendons and ligaments. Remember, tendons connect muscle to bone and ligaments connect bone to bone. I need that tensile strength to allow for that movement and leverage. So we see a lot of collagen fibers. You hear that term collagen a lot when we talk about like the skin and the makeup of when we get like lotions and things to take care of our hair and our skin. Reticular. Remember we learned the specific type of dense connective tissue and connective tissue proper. Remember we learned one of our reticular tissues and connective tissue proper. We see reticular tissue, it creates a framework for liver, spleen, kidneys. So when I look at it, it's like a mesh that helps create the support of the organ so it can carry out some of its functions. And then elastic fibers we see in areas of stretching. Another good example we use is blood vessels, specifically the arteries. As they pump blood, they have to allow for that movement of stretching to expand and contract so we can allow the different type of pressure of the blood going through. So connective tissue is different than epithelial tissue. No cellularity. Instead, we have cells that are making something. What's that called? The matrix. The matrix includes these specialized cells that are making a product that's called the fibers and ground substance. The primary fibers that we see are protein fibers, collagen, reticular, and elastic. This is connective tissue.